So question 7 says that the probability distribution of a discrete random variable x, so that's going to be important, discrete random variable x, is given by the table below. And it says, show that p equals 2/3 or p equals 1. So the first thing we need to remember is that the sum of all the probabilities p of x is equal to 1. So if we sum up all these guys here, that equals 1. So if we write that out, we have 0.2 plus 0.6 p squared plus 0.1 plus 1 minus p plus 0.1. That should all sum up to give 1. So if I combine all my decimals here and this one as well, I get that that is 1.4, and then I have minus p given by this term here, minus p, and then I have plus 0.6 p squared equals 1. So that's the equation there that I need to solve, which is a quadratic. So I'm going to probably turn this all into some whole numbers. So I reckon I'll probably times it by 5. So I'm just going to get the whole lot multiplied by 5, and that should hopefully clean up some of the numbers. So 1.4 goes to 7. So I'll write that out. 7 minus 5p plus 5 times 0.6 is 3p squared equals 5. So now, equivalently, I can write 3p squared minus 5p plus 2 equals 0. So all I'm going to do in that step, if I annotate in blue, is just to subtract 5 from both sides. So now with this equation here, all I need to do is solve for p, and hopefully I'll find that p equals 2/3 or p equals 1. So I think use the quadratic formula. So I know that p equals minus b plus or minus the square root of b squared minus 4 times a times c, all divided by 2a, where this is a, this is b, and this is c. So a equals 3, b equals -5, and c equals 2. So subbing that in, I get p equals minus 5 plus or minus -5 squared minus 4 times a times c divided by 2 lots of the a. So therefore p equals, and we're going to find that that gives -5 gives +5 plus or minus, and that's going to give me the square root of -5 squared is 25, and then 4 times 3 is 12 times 2 gives me -24 on 6. So under my square root sign, this just becomes equal to 1. So overall I have therefore p equals 5 plus or minus 1 on 6, and that gives me two cases. So one of them you should be able to see is 5 plus 1 is 6 on 6, p equals 1, and the other case is 5 minus 1 is 4 on 6, gives me p equals 2/3, and that's as shown, or as needed to be shown. So 7b wants us to let p equal 2/3 and then calculate e of x, the expected value of x for the discrete random variable. So we know that e of x equals the sum of x times the probability of x. So from that we can say that for this discrete random variable we have e of x equals 0 times 0.2 plus 1 times 0.6, which I'll write as 6 on 10 or 3 on 5, times 2/3 squared, plus 2 times 0.1, plus 3 times 1 minus p, plus 4 times 0.1. So then we've just got to go through and simplify all of this. And sorry, I should have replaced that p. We do in fact have 2/3 in there. So we've just got to simplify this down to get a number out. So the first one, 0 times 0.2 gives me 0, plus, that's going to give me 3 on 5 times, so that's going to give me 4 on 9, I think. So 2 squared is 4, 3 squared is 9. Then plus on 2 times 0.1, which is 0.2, plus 3 times 1 minus 2/3, which is just 3 times 1/3, plus 4 times 0.1, which is 0.4. So now we just go through another step of cleaning up. So we have e to the power of x equals, so 0, that's gone. So we look at the next one. 3 times 4 is 12 on 45, so 5 times 9, plus 0.2, yep, 0.2, plus 3 times a third is 1, plus 0.4. So that equals 12 divided by 45 plus 1.6. And now we just have to turn it all into something that can be collected. So I think, what can we do here? So let's go 12 on 45 plus 1.6 can be written as 8 on 5. And then if we times the top and the bottom by 9, we can have 12 on 45 plus 72 on 45, which gives me 84 on 45. And then what can we simplify that down? 1, 2, 3 goes into the bottom one, and 3 goes into the top one. So I think we can simplify that down into 28 on 15. So I hope that's the correct answer. That's as simple as I think I can make it look. So then the second part of B says find the probability that x is greater than e of x. So previously we said that the expected value of x equals 28 on 15, which is, if we think about it, just a fraction smaller than 2. So that's smaller than 2. So therefore we can rewrite this line as being the same as the probability that x is greater than or equal to 2 for the discrete random variable. And the probability that x is greater than or equal to 2, so PR that x is greater than or equal to 2 is just the probability that x equals 2 plus the probability that x equals 3 plus the probability that x equals 4. So there are the the 3 possibilities that satisfy this. So in that case we can just pluck them out of the table. So here we'd have that's equal to, so the first term, if I do it in blue, that's 0.1. The second term, if I do it in red, is 1 minus p, which is 1 minus 2/3. And then the fourth one, the third one, prx equals 4, if I do in green, is just 0.1. So if we add those together, we get that that's equal to 0.1 plus 1/3 plus 0.1. So the probability is then going to be 0.2 plus 1/3, which I could rewrite 0.2 as being 1/5 plus 1/3. The most common factor is 15, so we could have 5 plus 3 on 15, which is 8 on 15. So that's the probability that x is greater than or equal to 2, which satisfies this initial condition here, which is what we were asked to find.